this is Mr. Burgess. We're going to talk about estimating the solution to a system of equations that may not fit or overlap each other right at an intersection, but somewhere out in no man's land. But before we do that, let's just review a couple of the kinds of questions we've been asked the last couple of quizzes, and that we keep trying to get you to understand to make sure that you'll do well in the future. So if we are asked to graph this system and then solve it or find where it intersects, let's go ahead and do that. So the first one's already solved for y and is in slope-intercept form. So my y-intercept is at -3, and I'll make a dot there. The slope says positive 1/2. So from here, I'm going to go up 1 and over 2. That represents that 1/2 we're talking about. Up 1 over 2. I'm going to do that a couple more times just to kind of keep the pattern going so I know where my line's going to go. And it's a lot easier to make it when you've got a lot of dots to line it up with. So if I get my line tool and stretch it out on there. Oh, I didn't take my line tool. Well, I guess I drew the line, but let's just go ahead and do the next problem then while we've got a marker here. So on this next one, we're going to minus 5x from both sides because this one has not been solved for y yet. Minus 5x. So we've got 4y equals minus 5x. On some of our recent quizzes, I saw several people, when they moved the 5x over to the other side, forget to turn it to a negative. And so when they graphed it, the line had the wrong kind of slope. So let's get this straightened out. So y equals -5/4 x plus 4. So we go to the y-axis, put a dot at 4, and then we go down 1, 2, 3, 4, 5 for our -5, and then we go 1, 2, 3, 4 to the right for that 4 there. When we connect the dots, there is our intersection at 4, -1. And that's how you graph a system and then see where they intersect, and that becomes your solution. That's the x and y value that makes most of these equations true at the same spot. On this next one, we're going to find the x and y intercept. So we divide the equation in half and just set each half of the equation equal to that 4 over on the right-hand side. And on this one where we have y equals -4, well, I forgot to put a negative right there. Don't forget that negative. So if there's nothing left in front of y right here when we divide this equation into two parts, that is the y-intercept then. We didn't have to divide by anything, so the y-intercept here is -4, and we go ahead and mark that. The x-intercept, to find that, we have to divide by 2 first to get x by itself. And after we do that, we find out that the x-intercept is going to be -2, and we put that right there. And if I had forgotten to put that negative on the 4, we would have erroneously gotten a +2 for our y-intercept. But it was -2, so when we graph it, there is our graphs using x and y intercepts. Okay, so today, like we said, some of our equations, when we solve them and when we graph them, are not going to meet in a perfect and show you what we mean. Well, first of all, look at this one. You notice how they cross right there? So today we're going to come up with some numbers for that location just by estimating as best we can. They're not going to be perfect, but we ought to at least be able to get close, right? So we know it's going to be an x value and a y value. And let's just kind of come up with some. Looks to me like the x value right here is probably over at about 1.6. Over 1.6 You might have said 1.65 or 1.7, I don't know. And then the y value is not up very far. It's only up about 0.25. So it's not up very high off of the x-axis. So you could do it like that, and if you're within reason, we have to give you the right answer or give you a correct response. Now, if your numbers are way off, of course, you'll still miss it. Now, we could agree to just estimate it by going to the nearest intersection. Like in this case, it would probably be 2, 0. But that would be off quite a bit, so we're going to just go ahead and stick with this for now. And as we go through these, and then during class, we can kind of decide what to do from there. All right, how about this one? This one, you've got a coordinate right here. That's where they cross. So if we estimate where those cross, those almost look like they cross close to the middle, but not quite. So why don't we agree that we're going to just say let's estimate that this one crosses at minus 0.5 and 0.5. Minus 0.5, both of them. So back 0.5 and down 0.5, and that's going to be pretty close. Now in future lessons, we'll show you how to find the exact answers on these using algebra. But for now, we're just estimating using graphing. Okay, so not too bad. How about that one? Now that one looks very similar to the one we did 2 examples ago. So the x value would be about 8.7. So over 8.7 and up, oh boy, that's not very far at all, up about 0.2. And you're just estimating. And because you guys are smart junior high kids or whatever students are watching this, you have enough number skills to know that that's up a little ways. 0.2 might even be a little high for that. Might be more like 0.15, but if we're within reason, that is a good estimate because that's what we're doing, estimating. All right, let's try another one. In this case, we actually have to graph it and then see if we get that type of a problem to deal with. So we got a y-intercept on our first one of -2, and our slope is +3, so we go up 1, 2, 3, and then over 1. 1, 2, 3, over 1, or 1, 2, 3, down and back 1, it still gives us that +3 slope. All right, so we got that line almost ready to go. Let's change our color and let's get this next one, the dots on this next one ready to go, and then we'll graph both lines. So we've got a y-intercept of +3 and a slope of -1. So we're going to go down 1, over 1, down 1, over 1, down 1, over 1, and so on. So now we're going to graph these lines and just see where they actually intersect at. So let's start with the blue line that comes up through here like this. That's pretty close. We'll actually get a hold of that line and just slide it back over a little bit right here so they line up a little bit better. Sometimes it's kind of tricky. Anyhow, there we go. So there's our blue line. In fact, we can click on that. We can even change the color to blue. So there's the blue line that went with the blue dots. Now let's check out the green line. So let's get another line and get a graph coming down through here. Ideally, these are supposed to go all the way through, right? So if you stretch that out a little bit. There we go. Okay, so we do see, after we color that line in green, we do see that they intersect. Oops, jumping the gun here. We do see that they intersect right here. And that's not in the middle, not right on one of these places where 2 main lines cross. It's kind of in the middle. So let's estimate our solution. So our x value is going to be over 1.2, or 1.2, let's do 1.25. And our y value is going to be up 1.7 or about 1.7. Let's say 1.7. And we could have differences in opinion about where that's at, but we got to be close. You might have said 1.75 or 1.68 or something, but we're within reasonably close to being to each other's solution. And then, as time goes on, if we want to make some rules that say, okay, we got to go to the nearest easy to identify location, we can decide that. But for now, we're just doing the best we can. And that's kind of fun because we don't have to have an exact answer as long as we're close. Okay, let's try one. And in this case, we actually have to solve one for y. So let's solve this one for y before we graph them both. And that will give us practice solving for y. So we're going to add 12x to both sides. And that became positive because we moved it across the equal sign. So we've got 2y equals 12x plus 6. Then we divide by 2, and y equals 6x plus 3 is our equation. So let's graph both of those. So the first one up here we'll graph with a blue marker. So we go to -2. Then our slope is up 1 over 1, 2, 3, 4. Or down 1 and back, 1, 2, 3, 4. And on our last quiz, I saw a lot of folks, when we had a graph or a slope of 1/4, they went up 4 over 1. They got it backwards. Okay, our next line we're going to graph with red dots. So that one has a y-intercept of 3 and a slope of up 6 and over 1, but we don't have room to go up 6 and over 1. So we're going to go down 6, 1, 2, 3, 4, 5, 6, and back 1. So that's going to come through there. Now we'll get our line tool, draw a line up through those first 2 dots. And we got to kind of get make sure that we get the line to go through the dots, not just to the side of them or something like that. That's pretty close. All right, our next line, we're going to go through the blue dots. We just went through the red dots, now we're going through the blue dots. As we can see, we actually have an intersection there, right about there. So that's not in the most convenient place, but if we look at it, that's about -0.8. So our x value is about -0.8. And our y value is -1, 2.3. -2.3. And that's a good enough estimate for that point. If you have a little on our worksheet today, if you do a little bit of a different number, as long as you're within reason, we will give you credit for it, and we'll have an answer key available. All right, is that it? That's it. So our worksheet today is estimating systems by graphing. So you're just going to look at the graphs. I don't even know you have to graph too many of them yourself. You're just, for the most part, you're going to be looking at the graphs and writing down a solution as an ordered pair. So good luck with that, and have a little bit of fun. Thank you very much.